Thank you.
Which ones?
So we did 392, 1 to 3, 5, and 7.
Alrighty, let's start with 1. Use transformations of the cosine function to write 3 equivalent expressions for the following graph. Okay, so the rubric is this, right? A, K, D, and C. Step 1, I think the easiest one would be to find C, which is the axis of symmetry, the equation of the axis. How do we find this?
Wait, I thought that this one is just asking you to write it in like like to write different ones, no?
Yeah, it says use transformation, so I think it's gonna have, it'll be something like this, like 3 cosine x minus pi over 2 or something. Something along those lines.
Okay. So axis of symmetry is 0.
0, right? What's the amplitude?
Amplitude is 1.
1. What's the k value, which is the 2 pi over the period?
The period is going to be 2 pi, so it's just going to be 1.
1, exactly. Now the d is the thing that we can use, right? D, we can use 3 different things. So let's use this one. So if d is minus pi, okay, the first answer to this is going to be cos x plus pi.
Wait, what's d again?
D is the horizontal shift.
Okay.
So this is one of them, okay? And then actually it's starting at a minimum, so this will be negative. The amplitude will be negative if the cosine function starts at a minimum. The next one, we can do this one. So the d value there, it's shifted 2 pi to the left, so it's going to be positive because it's starting at a maximum, x plus 2 pi.
I'm confused about the negative and positive part.
Oh, if it starts at a minimum, amplitude is negative. If it starts at a maximum, the amplitude is positive because the parent cosine function looks like this. This is y equals cosine x. And this is y equals minus cosine x. So if it starts at a minimum, the amplitude will be negative. It's a reflection on the x-axis.
Okay.
Like here, this will be negative. You see, if we put this, well, it's going to be the d value. The d value will be positive pi. And so it's going to be negative 1, which is the amplitude cosine x minus pi, like that.
Yeah, because you want to. But why minus pi?
Oh, because a minus means it's shifted to the right.
Oh, shift to the right and it's reflected.
Yeah, exactly. Because it's starting at a minimum, it's going to be a minus sign there.
Okay. I get it.
So that's for the cosine function. B is asking us for a sine function. And again, it's asking us for a different function. The only other function that could work here is a sine. Tan doesn't work and none of the reciprocals work either. So the only thing we could do is sine. So AKC will be the same. Well, A can be positive and negative. The only thing that changes is the D value, okay? So sine function, it starts at the axis of symmetry, the equation of the axis, right? So we can use this one as one of them. We can use this one. And then I don't know, we can use this one. Let's look at the first one. What's the shift?
Shift is pi by 2 to the left.
Exactly. So it's going to be sine x plus pi over 2. What about the second one? What's the shift?
Minus pi by 2.
Exactly. So sine x minus pi over 2. Now remember this, just like with the cosine function, if it's going up from the axis of symmetry, it's going to be positive sine x. If it's going down, it's going to be minus sine x. The amplitude will be negative. That's why if we're using this point, this is going to be a negative here.
Okay.
And for the third one, it's going up. So it's going to be sine x minus 3 pi over 2. 3 pi over 2 units to the right.
And I remember my teacher said something about like, there's a thing where you can write like n in front of it, and then you can have like infinite number of answers.
Right. So
how to do that again?
It doesn't apply to this question though, because this one's just asking us for 3. That one we'll do when we're doing equations.
Okay, but like, say I wanted to, would it be like plus n pi over 2 or minus n pi over 2?
Um, in this case, it's going to be positive or negative. It's not going to apply to this question. It only applies to like solutions. You know, when you solve a trig equation, and when you're writing the solution, it applies to that. So it'll be something like n times pi over 2. Like for example, if we're trying to solve sine x equals 1, yeah?
Yeah.
So sine function looks like this. Okay, when is it 1? It's 1 at 90, right? At this it's 0, at 3 pi over 2 it's negative 2, and then at 360 it's 90 again. Yeah, 0, this, not 360, sorry. What comes after 2 pi? 5 pi over 2, right? Yeah, so look at this. The solution to this, what's the period here? It's gonna be every 2 pi, it's gonna come back at 1. Yeah?
Yeah.
So the solution of this will be x equals pi over 2 plus n times 2 pi.
Because you translated it to the right.
Yeah, so the solution repeats every 2 pi units.
But I thought it would be minus pi over 2 because you moved it to the right.
No, this is not transformations. Okay, we're not doing transformations. So what this means is that x equals pi over 2 is a solution, and x equals pi over 2 plus 1 times 2 pi is a solution, which is 5 pi over 2. Okay, see this one, pi. This is not a transformation question. And then the next solution would be pi over 2 plus 2 times 2 pi, which is 4 pi plus pi over 2, whatever that is.
Okay.
Okay, so this n times applies to when you're solving trig equations, not when we're doing transformations like we have here.
Okay.
Classify the reciprocal trig functions as odd, even, and write the corresponding equation. All right, this is the idea about odd and even. If it's an odd function, okay, if you have f of minus x, you'll get minus f of x. And for an even function, if you have f of minus x, the minus sign just literally disappears from the function.
Even.
These
So
are
it
the
doesn't do
conditions.
anything.
It does not. The minus, it just kills the minus sign. Like for example, if f of x is x squared, okay, what would f of minus x be?
X squared is all.
Yeah, exactly. It's going to be minus x whole squared. It's going to be x squared, which is the same thing as f of x that we started off with. Therefore, x squared is an even function. In terms of trig, it's going to be cosine. Like if f of x is cosine of x, okay, what would f of minus x be? It'll be cosine of minus x, right? Now, what does that mean? Look at the, let's use a cast rule. X here just represents an angle, okay? If this is x, minus x means we go clockwise, right? This will be minus x, right?
Yeah.
That's a related acute angle. Is cosine positive or negative in quadrant 4?
Positive.
Exactly. So cos of minus x, it would be the exact same thing as cos of positive x, which is f of x. Therefore, cosine x is an even function.
But thing is, I was confused about when you see it from like a graph point of view.
Okay, so graph point of view, if it's symmetrical, it's going to be an even function. So for example, quadratic x squared. See, whatever you have on the left, it's a reflection on the y-axis. That's an even, yes. And cosine function looks like this. You see, whatever you have on the right, you have the exact same thing on the left. That would also be an even function.
Okay. What about odd?
Odd function is this condition, okay? So for example, if f of x is x cubed, f of minus x would be minus x cubed, which is the same thing as minus f of x. In terms of trig, a sine x is an odd function. So f of minus x would be sine of minus x, and sine is negative in quadrant 4, so it's going to be minus sine of x. This is how to do it algebraically. Graphically, it's basically it's a reflection along the diagonal. Like there's no, see, like here, whatever you have down here, you have the same thing up there diagonally.
Well, that's how I don't get. How is that a reflection diagonally?
Well, that's just a phrase of term. So whatever you have in Q3, right? If you take this piece, yeah,
Mhm.
if you rotate it, like, what is this going to be? Like 270 degrees. You first rotate it this way, and not 270 actually. It's going to be 90 would make this way, and yeah, it is 270.
Oh, you go like that,
Yeah.
that.
Like sine of x, it looks something like this. Whatever you have in quadrant down here, you have the same thing up here. Whatever you have here, it's going to be the same thing down here.
I get it now, yeah.
Okay,
Okay.
so that's sine of x. So again, if cos of x is even, that means secant of x, the reciprocal function is also going to be even, and that's the case for this one. Secant of x is even, and cosecant of x is odd because that's the reciprocal of sine, and sine is an odd function.
Yeah, what were you saying about like the quadrant 4 thing?
Oh, I'm just saying reflected from quadrant 4 to quadrant 1, like diagonally, like a rotation of 270 degrees.
No, like you were saying like in quadrant 4 sine is negative.
Oh, using the cast rule.
But like how do I know how big x is?
Oh, you don't have to know how big x is. Look at this. So f of x is sine of x, okay? X here represents an acute angle, okay?
Well, it has to be a cube.
Yeah. So that means f of
Okay.
minus x is going to be sine of minus x, and that's negative in quadrant 4. So this is the same thing as minus sine of x.
Okay, yeah. I feel.
Now the question for you is, what about tan?
Tan becomes cotangent.
Oh, correct. Oh no, wait, what? I
Wait,
meant
no.
like, is it even or odd? That's what I
Oh,
meant.
it's think it's odd
How can you tell?
because it's reflective about the origin.
Yes. Algebraically, f of minus x would be tan of minus x, and tan is going to be negative in quadrant 4, so minus tan of x. So that's an odd function. So tan and cotan are odd functions.
Okay.
Cool. Does that make sense?
Yeah, I get it.
Um, what in the world is this? It doesn't matter. We'll figure it out. Use the cofunction identities to write an expression that is equivalent to each of these. So I think for this one, we're supposed to use this chart. Right, sine of pi minus 6.
Sine of pi minus 6.
We need something that's equivalent to that.
So it's gonna be cos.
No. It has to be in terms of sine.
Oh, okay.
We just need to write an expression that is equivalent. So look at this, sine of pi over 6, yeah? This is positive, right? This is acute, it's in quadrant 1. Where else is sine positive?
In the third one.
Correct. No, not the third, the second one, right? Q1, Q2, here.
Oh yeah.
CAST castrol. So we're going to use this one. Okay.
Okay.
So this will be the same thing as sine of pi minus pi over 6. And that's going to be sine of 5 pi over 6. And that's the answer to this question.
I thought that in the textbook I thought that it said cos to use cos of that one.
Cos? No, it says use cofunction identities. I don't think it means cos.
I think because what I have is cos pi over 2 minus pi over 6. I don't know, like that's what it says in the answer. Let me check.
I mean, there's something that exists. I can write this in terms of cosine, but I don't have the thingamajig. I guess this one. You're right. We can use this one.
Yeah, I'm just trying to see like if I'm tripping or not.
No, you're not. So I was using the one on the bottom, yeah.
Oh yeah.
You can use this one as well. Okay, or we can use a combination of both of these. Cool. So let's try using this
It's
one.
like the pi/2 one.
Yeah, let's use this one. If they want pi/2, we'll give them pi/2. So sine of pi/6, right? That's going to be equals to cos of 90, yeah, minus pi/6.
Okay. Yeah, I think I understand these. You just have to plug it in.
Yeah, you just have to plug it in, and you can use a combination of. Actually, all of these are in quadrant. Yeah, all of these are acute, I believe.
Yeah, I think this question is just acute.
Yeah.
And then I think I had a question mark on 5A. I don't know why.
Oh, this is what I was trying to do earlier.
Yeah, bro, that's why I keep getting confused. What do I use? Like, because they only use sine in this one.
Right. So if they ask you to use cofunction, you want to use this one, right? Cofunction means not sine, something else. I think that's exactly what that means.
Something else. And
Yeah.
then when it's saying, what is this? Equivalent?
Yeah, exactly. You use sine, yeah.
Okay.
So for this one, again, what is this angle? Which quadrant is that angle in?
Quadrant 2.
2, exactly. Is sine positive or negative in quadrant 2?
Positive.
Right, so where else is sine positive?
Quadrant 1.
Yeah. So all we have to do in this question is, if this is 7 pi/8, yeah? What is this? What's the related acute angle?
Pi/8.
Pi/8, and that's it for this question. So sine of 7 pi/8 is the exact same thing as sine of pi/8.
Well, so what am I trying to find? I'm just trying to find the related acute angle.
Correct. Here, let's do another one. B, okay?
What's the point of having sine though?
Oh, that's just the function that they have given us.
But
Oh, the fun, no,
there's
it has a purpose. It's to use the CAS rule.
okay,
Like, let's look at B, like B. So 13 pi/12, take my word, it's in quadrant 3, yeah?
Yeah.
This is 13 pi/12. What's gonna be the related acute angle? It's gonna be pi/12, right?
Mm-hmm.
So this means cosine, and again, cosine is negative in quadrant this, okay?
Oh, so then you're right.
Yeah,
Negative.
exactly. So cos of 13 pi/12 is the exact same thing as negative cos of pi/12. Yeah, if it was tan 13 pi/12, it'd be positive tan pi/12.
Yeah, I don't know why I was doing addition, because in this question they also did addition.
Yeah, so the addition is to come up with the related acute angle, right?
Yeah, I was so confused. Why are they doing pi plus 13 pi/12?
It's gonna be pi/12 or 13 pi/12 minus pi. They're just trying to find the related acute angle. So if you know how to do that, you don't need to do exactly what they did.
Yeah, I don't know. It's kind of weird.
So here, this is a rubric, okay, for the related acute angle. Theta represents the principal angle. In quadrant 1, theta is alpha. In quadrant 2, theta is gonna be 180 minus alpha. Or alpha is gonna be 180. Wait. Let's do pi. Alpha is gonna be pi minus theta. In quadrant 3, alpha is again the related acute angle. Yeah.
Mm-hmm.
It's gonna be theta minus pi. And in quadrant 4, your alpha is gonna be 2 pi minus theta. Like for example, let's do F, right? F. Tan.
How come they use 3 pi/2 though?
Say that again.
Like I know they use 3 pi/2 sometimes, but why did they do that?
3 pi/2 would be down here, right?
But like, is it like you can use it 2 different ways? Like I can do
No, technically you're supposed to go from the horizontal. Like well, I'll show you here. Tan of 5 pi/3, yeah. Our theta is in quadrant 4, and that's our principal angle, right?
Mm-hmm.
What's gonna be the related acute angle?
It's gonna be pi/3.
Correct. So tan, how did you find that? See, that's what they're doing. How did you find pi/3?
I'm not gonna lie, I just looked at how I did it before.
So you want to use this one, right? See, it's in quadrant 4, yeah?
Yeah.
So your related acute angle is going to be 2 pi minus 5 over 3, and 2 pi is 6 pi over 3 minus 5 pi over 3. So it's going to be pi over 3. So tan of 5 pi over 3 is the exact same thing as tan of pi over 3, except in quadrant 4, it's a negative.
So I just plug it in the formula that we have,
Yes, correct.
and I put the negative if it's negative.
Yes, use a cast rule. So you just got to use one of these, and it's always going to be one of these.
Okay. Yeah, I think I'm good for that one.
Okay, what else you got for me?
7. Oh, 7. I was so confused about like proving it true or false.
Have you learned the Have you learned the double angle formula, compound angle formula?
I think we briefly did it, but my teacher's trash. So I don't know.
All right, here, bear with me, okay? Cosine of A plus B. There's a compound
yeah,
angle.
we did that today.
Yeah. So it's gonna be cosine A cosine B minus sine A sine B. Now I don't know where this is exactly. It's right here. It's in the next section. So we can use this, one of these guys, to expand this per se.
Oh, that's how you do it. Because here they were just like plugging in a value.
Oh, that's the dumbest way of doing it, but that does work, right? If it works, it works.
I don't even understand though. Like, can you explain to me when you plug in a value?
But that's only going to be true for that specific value. Is it going to be when it says prove something, you got to prove it for every single value, not just for one. Here, let me show you how to do this one. Okay. What's happened here? This is a cosine, looks like this, right? What does this do? Plus 2 pi. It shifts it 2 pi units to the left, right?
Yeah, but it doesn't do anything.
Yeah, exactly. It doesn't do anything. This is going to be true because you see at 0, it's at 1. Yeah, the y value. If you shift it 2 pi units to the left, it's still going to be 1. Any value, it doesn't strictly have to be just the nice one. You see everything, if you shift it 2 pi, you'll get the same thing. So this is using transformations to do this.
Okay.
Right? Or you use this compound angle formula here. So in this case, it's going to be cos of theta times cos of 2 pi. What's cosine of 2 pi? It's a 1, okay? Minus sine of theta times sine of 2 pi. Now check this out. Sine of 2 pi is a big fat 0. So this term completely disappears. And then you have cos theta times cos of 2 pi, which is a 1. And that's the same thing as cos theta. And there we go. That's doing it algebraically. And this rule applies for any angle theta, not just one specific.
Like, how come, like, okay, say for B, it's false, right?
How do you know?
I remember it was because they let a value, like, just let a value on one side, it's going to give you, like, a different value on the other side.
All right, yeah, I guess you can always do it that way, yeah. But eventually you'll see that when we're doing proofs, you can't just plug a value in and call it a day, because just because it works for one doesn't mean it works for all of them.
So you actually have to prove it.
Yeah, you will do it when you're proving trig identities in 7.4, I believe.
Okay.
Any other questions from this section? Because that was the last one there, no?
Yeah, from this section, we're good. So this is the thing I was doing today. I kind of get this a bit more. So it's page 400. And then I'll tell you which one I was confused. Number 3D.
3B?
3D.
D, all right.
Like, I was just wondering, can I have two different answers that are right?
Yeah. Sure. Yeah, you can. What's the question asking you? Using a pair of angles from the special triangles. So pi over 12 is 15 degrees, right? So you can either do 30 or 45 minus 30, right? Let
Yeah.
me just double check. 180 over 12 is 15. What else did you have? So the answer to this is going to be pi over 4 minus pi over 6.
Yeah, and the one that I did was pi over 3 minus pi over 4.
That'll be negative 15. Say that again.
No, pi over 3 minus pi
Oh yeah,
over.
that works as well. Yeah, so 60 minus 45 also works. So yeah, that's right.
Okay, good. I'm ready. For 8C, 8C is the other one I was doing.
Right.
Like, for that one, can you tell me like how you think about it when you're doing it?
Okay, so you want to think about it in terms of the related acute angle. First, find the related acute angle, or write it in the form of related acute angle, and then you want to come up with the 45, 60, 30 in terms of the related acute angle. So in this case, the related acute angle would be what? It would be pi over 12, exactly. And it's in quadrant 4, right?
Yeah.
So cosine of 11 pi over 12 is the exact same thing as cosine of pi over 12, step 1. Okay,
Wait, and that's gonna be
that's
because it's gonna
15.
make negative.
That's 15, yeah.
Mhm.
Now you can either write this in terms of like you did, like 60 minus 45, or you could also do like 45 minus 30. Both would work. You'll get the same
Oh,
answer.
and in that, but you're saying in that quadrant it's going to be positive, but I think it's negative.
It's quadrant 4, no? 11 pi over, no, yeah, you're right. It's not in quadrant 4. It's
Yeah,
in
it's
quadrant
quadrant 2.
2. Yeah, I'm thinking of something else. Yeah, you're right. It's going to be negative. Just put a
Okay.
negative sign here.
Like, you know, at the end of your answer, when you have like the negative outside of the bracket while solving,
Mhm.
like, do you always have to expand, or can I just leave it as like negative root 6 plus root 2 over 4?
So you can leave it as this, whatever you got here.
Yeah, I can just leave it like that.
Yeah, on the outside. But if you throw it in here, then you have to, yeah, you have to do it like that. Both will be
But
right.
when I throw it in, do I have to do the denominator as well?
No, just only do once, either on the top or on the bottom.
Okay, either denom or numerator. Okay. Okay, and also, what thing do you use like when you take notes like on your computer thingy?
Like what software am I using right now?
Yeah, that thing.
It's called Open Board.
Is it also on Apple or?
I can check.
Because like I've been using some, but they're not that good.
This one's pretty nice. I like this one. Yeah, it is. It's on a Mac.
Okay. Let's see. And then the other one we're doing is 9. Number 9.
That one looks interesting.
Yeah,
And
I
this is
had
not a
no.
special angle. Yeah, this is not a special angle either. So, or a special triangle angle like 30, 60, 45. All right. Which one do you want to do? They're all the same, to be honest.
Let's just do E.
Okay, we'll do E. So they want tan x plus y, yeah?
Mm-hmm.
All right, this is gonna be fun. So tan x plus y uses tan x and tan y. So step 1, we're gonna find both of these guys individually, okay? And then we're gonna plug that into this formula.
Okay.
Let's first find tan x. So tan x is gonna be sine x over, actually we don't even need that one. We can just draw the triangles. So let's check this out. So x is acute, you see that?
Yeah.
It's between 0 and 90. So we're gonna draw a triangle in quadrant 1. Okay, like this. And this is our angle x. We're not concerned with what it is, what the angle is exactly, but we know it lies in quadrant 1. Now, what are the sides of this triangle? Look at this. They've given us a ratio.
And so that's gonna be opposite over hypotenuse.
All right, so the opposite is going to be 4. The hypotenuse is going to be 5. And just remember this, 3, 4, 5 is a Pythagorean triple. So the bottom side must be a 3.
Okay.
Another Pythagorean triple that comes up is 6, 8, and 10. And then
Oh,
there's
you have
5,
so many
12,
of them?
13. Yeah, there's an infinite of them. And yeah, infinite number of them. Imagine how they proved that. That's what very difficult maths. Like they've proved that, like these triples, there's an infinite number of them.
Yeah.
Now the question is, how in the world did they prove that? And that's way beyond our scope, but you can look it up if you want to do something math related eventually. Anyways, so we first established to solve this, we need tan x and tan y, right?
Mm-hmm.
Step one, we'll find tan x. Now tan x is going to be opposite over the adjacent, right? Therefore, tan x must be 4/3.
But we're not even doing the y part.
Not yet. We're going to do y part next. Like I said, we first find tan x, and
Oh,
now we're going to find tan y, okay? Let's look at y. In which quadrant is y in?
so it's saying it's in quadrant 4.
Right. So we're going to draw a triangle in quadrant 4, okay?
Mm-hmm.
All right. So again, this is opposite over the hypotenuse like that, right? And I just
And then
told you
there's a
this,
negative
it's going to be
somewhere.
5. Don't worry about the negative just yet. The negative is to show that it's in quadrant 4. Tan is also going to be negative here.
And is it true that hypotenuse is never negative?
None of the sides of the triangle are going to be negative, but you're right, hypotenuse is not going to be negative.
I'm confused about that. Like, what's the point of them putting a negative though?
Oh, this one?
Yeah, like, do I ever look at the negative in that situation?
Not necessarily. You just want to, well, because it's in quadrant 4, sign must be negative. That's why. Using the casserole, only cosine is positive in quadrant 4. Well, when you're drawing the triangle, you can ignore the negative sign because the triangle is length, right? And length is not negative. So now that we've established, we have 5, 12, and 13. So tan y is opposite over the adjacent. So tan y must be 12/5. Now is when you want to take into account the angle. Tan must be negative in quadrant 4. And there we go. That's what tan y is.
And then I multiply those two fractions and that's it?
No, why are you multiplying? We're going to plug them into this formula here.
Oh.
Don't if you multiply them, you would get I don't even know what you get, tan x tan y. That's
I have no idea where I got that from. But
yeah. So the next one you're going to use this formula. So tan y, so it's going to be tan x plus tan y all over 1 minus tan x tan y. Tan x is 4/3. Tan y is negative 12/5. All over 1 minus tan x is 4/3 times tan y 12/5, like that.
Mhm.
And well, I'm lazy. I'm not going to do that by hand, but you can if you're feeling brave. My calculator gives it to me. I mean, so should yours if you know how to use fractions on your calculator. The answer to this is minus 16/63.
Okay, so and then all of them are the same for this? For this
What?
question, like all of them are.
The procedure is the same. Yeah.
I just plug it in the
Yeah.
equation.
Yeah, but for A, if you look at A, you need you need cos x, cos y, and you need sin x, sin y. Well, sin x and sin y are already given, so you just draw the triangles to find what cos x is and what cos y is, and plug them into that formula.
Okay. That should be good for that. Let me check the next lesson so see if I can get
Next
ahead.
lesson is gonna be a double angle formula, I think, yeah. And then
Um,
you're gonna combine all of them into trig identities, which is you're gonna find it's annoying.
yeah, the next one is double angle formula.
Mhm.
Can we start that?
It's just a different formula. Like it's literally the same thing. We're just gonna use a different formula, but this one's way more complicated than the last one. Let's try some of these.
Is it hard?
Well, the idea is the same. It's not hard per se, but like in the last one, we would add and subtract, yeah. To get like 15, we would do 45 minus 30. In this one, we're gonna have to get 15 by dividing 30. It's just a multiplication and division in this case. Here, let me show you one of them. So again, it's pretty straightforward. We know this is in quadrant 4, yeah? So we're going to draw a triangle in quadrant 4, and tan is opposite over the adjacent, yeah?
Yeah.
So that means hypotenuse must be 5, 3, 4, 5 Pythagorean triples. Now, now we're going to look at cos 2 theta. And this is the most annoying part. Cos 2 theta has 3 different formulas.
Yeah.
So I'm going to use this one.
How do I know which one to use?
You can use any of them. But the most efficient thing in this question would be to use the second one, because if you want to use the first one, you have to find 2 different things.
Yeah.
In the third one, well, I wanted to use the second one because cos is positive in quadrant 4.
Oh, but you can also use the
You can
last
use
one.
any one of them. You can use any one of them. Or let's complicate our lives. We're going to use the last one.
Okay.
So the last one, it needs sine theta, right? Look at this triangle. What's sine theta?
And theta is 3/5.
But it's going to be negative, right? Because it's in quadrant 4.
Mm-hmm.
So therefore, cosine 2 theta is going to be 1 minus 2 times sine theta whole squared. Okay, that's what that means. Sine squared theta means sine theta, the ratio, whole squared. So
Why
you
did
get,
we just thought like that at the start?
I don't know, but so we have 2 times negative 3/5 whole squared.
You're
That'll
right.
give us 1 minus 2 times 9/25. And again, I can do this by hand, but I'm not going to. That's going to be 7/25 as your final answer.
Okay, that's actually pretty light. Because everyone's saying that this trig unit's really hard. I don't know.
I find it very fun. But when you're doing trig identities, that's when you're gonna see it's very difficult.
Is that all I have to know for that lesson?
Yeah, it's basically all the questions are gonna be like this. No, it's a little bit more difficult here. Let's try another one. And if you can do this, I think you'll be fine for the rest of this lesson. It's this one. Just develop a formula for sine x/2, or better yet, let's find the exact value of sine 15, okay?
Mhm.
Or actually sine 15 you can do using the other one, right? You can use 30, yeah, you don't even have to use this for sine 15, but you could. What about this one? The question is, find the exact value of sine 22.5. Again, I told you in this unit, it's not plus or minus, it's divide or times. And almost always by 2 or by 4. It's that's relative, but yeah.
Well, where do you get 22.5?
That's just the question. The question's asking you to find the exact value of sine 22.5.
Okay.
Any ideas?
No idea.
This is where it gets complicated. You're gonna have to use one of these formulas, okay?
Yeah.
Here, I'll give you a hint. It's going to be this one.
Is it because cos is positive in that one?
Right. No, not necessarily.
And
There's nothing
tan?
to cos being positive. It's because this one is useless.
Yeah, you don't want to use tan.
And this one, it has cos and sine. So that's just needless because that's 2 different functions that we have to find, right?
Okay.
Even this one, there's 2 different functions that we have to find. We need to find sine and cos, and this one will give us cos, so this one's also useless. So there's literally, this is the only thing you could do. And here's the setup for this. If theta is 22.5, what's going to be 2 theta?
44, 43?
45,
Oh, 45.
right? So this is going to be, look at this setup. Cos of 45, yeah, is equals to 1 minus 2 times sine squared 22.5. See that?
Mm-hmm.
Now we're gonna move this to this side. We're gonna move this to this side because I don't like negative numbers or like this, okay? You don't have to do this step, but it's
Wait,
just cool.
this all you have to do and then you just solve?
Yeah, you just solve for this now. Step 1, divide both sides by 2. Step 2, square root both sides, but it's not going to be plus or minus because that's an acute angle. It's strictly going to be plus. And there you go. That's the answer to this question. And cos 45 is 1 over root 2. And this is the exact answer for sine 22.5.
Damn, that's actually not even bad. I thought it would be a lot worse than that.
Well, okay, it is way worse than this. Well, let's try doing one more. And this is going to be the most difficult one if it exists. Trying to see exactly what in the world I'm trying to find. Let's go one more level. Okay. 22.5 divided by 2. All right, what about this one? Find the exact value of sine 11.25.
Use the same formula.
So how do we set this up?
So you do cos and then 2 times 11.25.
So that'll be cos of 22.5, yeah, is
Mhm.
equals to 1 minus 2 times sine 11.25 whole squared. But here's the caveat. What in the world is cos 22.5?
Oh yeah, I don't know how to do that.
So for this one, this is a double annoying question. So this is a setup for the final answer, but before doing this, we have to establish what cos 22.5 is. For that, we're going to have to use this one.
Oh, you have to do it twice.
You have to do it twice, exactly. And guess what? Sometimes, well, this is so far, what did we do? Here we did pi over 8, okay, which is pi over 4 divided by 2. And this is pi over 16, yeah?
Yeah.
See, and then here we have to do it twice. And see, now it gets exponentially more difficult, or not difficult, but you just have to keep doing on it, right? What if I asked you for pi over 32, which is half of this? You see, it gets difficult very quickly. Because for
That's
this
like
one, you
the
have to do it
difference.
3 times.
Wait, I'm confused. You have to do it until you actually get like a whole number or what?
Like, not the whole number, like just what you have on the left-hand side of this equation.
Like I'm confused. What am I trying to get though?
Or you're trying to find what cos of 22.5 is to solve for what sine 11.25 is. So step 1, we're going to use this to establish what cos of 22.5 is. So cos 45, yeah, 2 times theta is equals to 2
Oh, you didn't have to
cos,
do it last time because we had 45.
yeah, see, like that. Now we're going to find what that is. That's going to be 1 over root 2 plus 1 over 2 square root. This is cos 22.5, yeah? I
And
just
then you
solved
plug
it.
it
Yeah,
in.
then you plug it in. Then you plug it into this one. But what if I asked you, this is pi over 16. What if I asked you pi over 32?
So I have to do it.
Yeah, you have to first find what cos of 11.25 is. And then you have to do it like 3 different times if you're starting from scratch. And, and if your teacher is really mean, he's gonna give you something like this.
But how do you even do that?
Oh, you're just same thing, but you're gonna have to do it like 8 or 9 times.
Until you get to like the
Yeah,
triangle thing?
yeah. So you have to
Okay.
first find what a pi over 512 is, and then yeah, like that.
It's
And
pretty dumb.
yeah, but don't worry about that. All right. Let's flip the switch. So again, I'm gonna give you the formula, okay?
Hmm.
And the question is, develop a formula, okay, for cosine of 8x,
Cosine of 8x.
right? Or simplify, or yeah. It looks like an innocent question, but it is not.
So I can plug it into the cos 2 theta thing.
Yeah, which one?
The second one.
Yeah, they would all work. So what does this expand to if you use that?
You do cos 2 times 8x, which is 16x.
No. 2
No?
pi is 8x. Okay,
Oh,
so you do cos of 2 times 4x, yeah? Theta is 4x, not 8x.
because that's already expanded?
Yeah. So you see this is 2. 2 is always going to be there. Theta is 4x. So this, and then you use this one, right? So that is going to be equals to 2 cos squared 4x minus 1.
Okay.
You're not done yet. You thought you were done. No, you're not. Now look at this.
Huh?
Cos 4x, we can also expand that. Cos of 4x is going to be cos of 2 times 2x. And using the same exact formula, this will be 2 cosine squared 2x minus 1.
Okay.
So this is going to be 2 times 2 cosine squared 2x minus 1 whole squared, because that's what cos of 4x is, minus 1.
Wait, why do you have to find cos of 4x?
Because we're trying to expand it. We're trying to develop a formula for cosine of 8x in terms of cosine of x.
Hmm.
And then you got to go one more level. You've seen Inception. We got to go one more level. The final level will be this. We need to expand this, and this is going to be, we need a bunch of brackets here. Everything else is going to stay the same, except this one we know is 2 cos squared x minus 1, just this guy by itself, whole squared minus 1 whole squared minus 1, and that's the final answer.
Cos squared 2x?
Mm-hmm.
Where is that formula?
Oh, it's from right here. Cos 2x.
Well, I don't even see that cos, but there's no squared there.
Yeah, because we had a squared on the outside. Oh, sorry, here we had a square from here, which came from here. I can look at what we did. Cosine of 2 times 4x, yeah?
Mhm.
And if you use the formula, this is what you get. But now we can simplify cosine of 4x using the same formula, and you'll get this one. See, the angle always halves. You see, we started out with 8x, then it became 4x, and then it became 2x, and then finally it became an x.
Okay.
So there's like 4 levels to this one.
But I was just confused because I don't see the squared in the equations. I only see 2 cos squared theta minus 1.
Yeah, and then the whole squared comes from here. Let's redo this because I don't want you to be confused. Let's just do it for a simple one. Let's just do 2 levels. So look at this, cosine of 4x, okay?
Mm-hmm.
That is equals to 2 times, not, oh, there's a cosine on the outside, but that's equals to cosine of 2 times 2x, yeah?
Yeah.
Your theta is 2x. So now using this formula, if you expand this, you would get 2, yeah?
Mm-hmm.
Cosine squared, and what's our theta? It is 2x minus 1.
Mm-hmm. I guess that, yeah.
You get that? Now we need to expand cosine squared 2x. Now check this out. Cosine of 2x, again, everything else is going to stay the same. The 2 on the outside is going to stay the same. The minus 1 on the outside is going to stay the same. But we need to expand this, okay? Using the
Okay.
same
But
formula, that is going to be cosine of 2x is 2 cos squared theta, or x, whatever, minus 1, yeah? And now check this out. You see there's a squared here? That's where that comes from.
2 cos squared x.
Because cosine of 2x is 2 cos squared x minus
Oh,
1. And then if you
yeah.
square this, you have to square this.
I see it now. Yeah, yeah. Okay, that makes sense.
And this is only 2 levels though. They will, like again, like the previous question, if your teacher's feeling funky, he's gonna ask you this. And
Yeah,
this one has,
this is infinite.
yeah, this one has 5 levels.
Well, that's so annoying.
So a question would be something like this. Given cosine of 3 is whatever, right? 0.222, whatever, doesn't matter. Find cosine of what's 32 times 3. Find the exact value of cosine of 96.
How do you do that?
Oh, you just take it into multiple levels. You first find, you do cosine of 2 times, what is this, 48? Yeah? You expand this, you'll get something squared minus 1, yeah?
Yeah.
And then there's going to be cosine of 24 here, and then you expand it, you're going to get double brackets, and then you expand the 12, it's going to be 6, you'll have triple brackets, and then finally you expand the 6, you're going to have 4 different brackets, and you'll have written the answer in terms of cosine 3.
But you're like, when they say exact value, what am I trying to find again?
Exact value just means you can't use a calculator.
So like I'm always trying to find like the related acute when we do that, or no?
Yeah. I mean, if it's a nice angle, then you're no, even this one is it doesn't necessarily have to be an obtuse angle though. Like it could be something like find the exact value of cos of 63. Okay. Here, let's do this. Find the exact value of cosine of 63 given, okay, given that cosine of, let me half this, 63 divided by 2 divided by 2. Given that cosine of 15.75 is whatever is A or something. Now look at the setup to this question. Cosine of 63 is the same thing as cosine of 2 times whatever that is, 31.5, yeah?
Mm-hmm.
Now using the formula, this is going to expand to 2 cosine squared 31.5 minus 1, okay?
Yeah.
Now what is cosine of 31.5? That is going to be 2 cosine squared, half of that, 15.75 minus 1.
Wait, why are you halving it?
Because it's a double angle problem. And I know if you half this, if you divide this by 4, you would get this. So I know this is a double angle formula. Like we did in the previous one. You see, we started out with 8x, we went to 4x, we went to 2x into x. We've been halving the whole, yeah, until you get the bare bones, which is this one.
So I'm trying to until I get close 15.75.
You're going to keep reusing the formulas. Now look at this. It's going to be 2 times, we're going to expand this. So that's going to be, we already have it, we just have to square it. It's 2 cosine squared 15.75 squared minus 1.
Mm-hmm.
And now see, we have the answer because cos of 15.75 is A, or they're going to give you a number. That's going to be 2 times 2. And this is A squared, yeah? Look at that.
Well, that is a, yeah.
Yeah, and then now you have the answer. So that's going to be 2 times 4a to the power of 4 minus 1. The final answer is 8a 4 to the minus 1.
Oh, and wait, where did you get the squared on the outside? That's from the equation?
The square on the outside came from this.
And why did you put it on the outside?
Because that's what that means, right? The squared on the outside means cosine of 31.45 whole squared.
So the whole thing, yeah. Okay, so like for this unit, like for the later lessons, are they harder or no?
This is as hard as it gets.
Yeah, hopefully this doesn't get harder than this.
No, trig identities is going to be annoying, like I said, because there's going to be some very, very tricky questions. So identities means you're going to have to prove something, yeah? And you don't know which one to use. Like, should you be using these guys, or you should be using the ones from the previous section?
Yeah, like how are you supposed to know?
That's the thing. You don't, like, unless you practice. And if you hit a brick wall, that means you're probably wrong. Like, see, the question will be something, well, there are some easy ones, right? Like, here it says prove that this is equals to this. Well, this, you can just use a double angle form, not a double, sorry, the compound angle formula that you learned in class today.
Okay.
And that's what they did. But something like this, even this one, you'd probably use a compound angle formula. But it's not always going to be as easy as that one. Look at this one.
Yeah, like I don't even, what even is it?
So this one is going to be a double angle formula because they've given you tan 2x and tan 2x. Okay, but sometimes it's going to get difficult. Like all the examples there are very easy. But you'll see that something like this is very difficult, like the D here.
Mm-hmm.
And if you're feeling funky, you can also do the extending ones, which is going to be difficult as well. This is a difficult part about this unit, it's just the trig identities. A lot of students have troubles because they hit a brick wall, like they're unable to prove it. Because most likely the path that they took was not incorrect, but just the wrong path to take in order to prove this question. And every question is going to be different.
Yeah. I think I just have to practice it a lot.
Yeah, you just have to practice it. Honestly, it's not that hard. It's like cracking a code, like or solving a puzzle is exactly what it feels like. There's multiple ways to go about it, but there's also the wrong ways to go about it. Even though the math is right, the method, the way to go about it is wrong. You should have used other formula than what you did.
Hmm. Okay. I'll practice and yeah, I'll let you know when I might need help again.
What else are you taking this? Chemistry or something?
Right now I have calculus and